that we can use. So
I
if
think it might be in person on the computer through web design because there's like that calculator that's like embedded within the website and like tools. Um, but if
all
not,
right.
I'm not really sure. Yeah.
Okay, so like they're kind of the shortcut to doing this, and then there's the correct way to do it. Do you want me to give you the shortcut, the correct way? What would be best for you?
I can do like learn both just so I have an idea of how to solve them and then see what would work easier.
Okay.
Yeah.
So the shortcut here is, and this may sound bad, but it's considered bottom heavy,
Hmm. Okay.
and then top heavy would be something different. So top heavy is like if this next to which is bigger, the fifth or the 10th?
The 10th is going to be bigger.
Okay.
Or yeah.
So bottom heavy means that this goes to 0. So the
Hmm.
answer is 0. Now that's like a shortcut. It's like, well,
Uh,
it's kind of magic. How does that even work?
yeah.
So to do this correctly, you identify the highest degree power, which
Uh-huh.
is x to the 10,
Oh, great.
and you divide everything, top and bottom, by the highest degree power,
Mhm. Okay.
like that. All right, so this is where your prerequisite courses come into play. So you're dividing each of these by that power there. And if you have to show work like on a test or a quiz,
Mhm.
like that, like this.
Like you're distributing the x to the 10th power amongst all like
Yeah,
the
yeah,
bottoms.
yeah. Division is sharing. It's not a choice. You have to
Yeah.
share with everyone. All right, so this becomes 10 over x to the fifth
Mhm.
plus 300 over x to the ninth plus 4 over x to the 10th.
Okay.
3 plus 7 over x to the 10. So if you're wondering where those numbers are coming from, it's the property that x to the n over x to the m equals x to the n minus m, like that.
Okay.
And if it's a negative exponent, like you can see here, 5 minus 10 is is negative 5.
Mhm.
The exponent goes to the bottom.
Okay. I see. I see.
So I will, you know, let me just, if it's x to the 5 over x to the 10,
Mhm.
5 minus 10 is minus 5, which is 1 over x to the fifth, like that.
Okay. Yeah, it's definitely a much longer process.
Yes, yes. And that's why, it's like, well, I don't, I'm all about giving you what you want, meaning what do you need here to be successful in this course?
Mhm.
So you're still doing the limit as x goes to infinity. And then kind of off to the side here, there's this property that says the limit as x goes to either plus or minus infinity, c over x to the n, this always goes to 0.
Zero.
So,
Okay.
so some examples would be like 10 over x to the fifth. That
Mhm.
goes to 0.
Mhm.
300 over x to the ninth goes to 0. 4 over x to the 10 goes to 0. 7 over x to the 10 goes to 0. So
Was it
basically you get,
ever like whenever the exponent is bigger on the bottom, that's where it's going to equal zero?
yes.
Okay.
So this equals 0 over 3, which is 0.
Zero. Yeah. Got it.
And you're like, well, okay,
Yeah.
well, that is the correct way to do it. And
Mhm.
that's, I mean, if you were going to take a lot of calculus, you'd want to know how to do this.
Mhm.
If you don't care, it comes down to this, whether it's top
Mhm.
heavy or bottom heavy. If
Yeah.
it's bottom heavy, it goes to 0.
Okay, that makes sense. Yeah, I think
Bottom heavy
I
means biggest
honestly might do
exponent.
the shortcut way because like the first three I did the shortcut way and he did show us that like theorem in class. So I think some people have just been doing that like the faster way instead of breaking it down. Okay, yeah, so I'll submit that. Okay, got it. Okay, we can work on 5.
Let's take a look here. All right, assume A, B, C, and D and E are non-zero constants, then compute the limit algebraically. Again, like we don't have to do it the full way.
Mhm.
We can just do it where it's kind of a shortcut, or we can do it the full way. What would you like to do here?
I guess we can do the shortcut because that's
Okay.
what I've been doing.
So you have to identify the highest degree term in the top and the bottom.
Okay. And that's
Minus a squared b x squared over minus a b x squared like this.
Mhm.
Now this one is neither top heavy nor bottom heavy because these
Right.
are the same.
Equal. Yeah.
So they just cancel out and you're just looking at the ratio here of this, which is the negatives cancel,
Mhm.
B's cancel, and then that A canceled that A. So it ends up just being A.
Okay.
And with WebAssign, I think, you might look in the details. I think you probably get like 3 choices. Sometimes they give you enough where you can always guess. So you get the right answer.
I think so. Yeah. I think for our homework, we only get one attempt and like no hints, I think. Or let's see. I'm looking at it. Oh, wait. Yeah. We have 3 submissions. Okay. Details. Okay. Got it. Yeah. That was correct. Okay. So would question 6 be the exact same thing? You're just seeing what you can cancel out?
So 6 is slightly different because it's bottom heavy.
Okay. Right.
I'm sorry, forgive me if anyone listening and feels like that's a negative thing. It's all math. We're all talking about math here.
Mhm.
Squared bx squared over minus a bx cubed. Uh, those are what's called the power terms, and they're the highest degree terms. So because this is bottom heavy,
Mhm.
it goes to 0.
Because
Meaning,
3 is greater than 2.
yes, exactly.
Oh, okay. Okay, I didn't realize how simple that was. Okay, he didn't talk about the bottom heavy and like top heavy rule, so I was like, what is going on? Okay. Okay, so I submitted that, and then okay, I'm on number 7 now. Um, is this one similar to like 4? Because we're looking at like the limit going to positive infinity.
Yeah, we're talking about 7 now. Sorry, I just
Yeah.
got sidetracked on
Yeah.
something. Right. Okay. Yeah, I mean you look to see, is it top heavy or bottom heavy?
Mhm.
Um,
Okay.
it's the same.
Okay.
So it's 1x to the 6 over 2x to the 6. So like you said, it's like 4.
Mhm.
No, it's like 5 where you just look at the ratio of
Yeah.
these. Um, and so it is 1/2. If you
Right.
haven't used WebAssign in a while, you are allowed to check this part before moving on to this other part.
Mhm.
So you may consider doing that. If you're not checking these as you go, like please do. Sometimes I
Yeah.
I
Oh yeah,
give you
I'm
bad
checking them
information.
as I go.
Okay.
Yeah, there isn't an option to submit like the 1/2. You have to like
No.
submit the whole thing once.
Okay.
Yeah.
If the limit does not exist, say why. Well, the limit does exist and is a finite number. There
That's
we
what-
go.
Got it. Okay. Yeah, that was correct for both. Yeah, it should checks for like the 2-parter. Okay. Okay, I guess I'll try the next one, 8. Let's see. So the exponents are the same. We have like x squared in the top and bottom.
Yep.
And would it just be simplified like what's 16 over 4? Would that just be 4?
Yes.
Yeah. And then so the limit does exist, and is it still a finite number? Because
Yes. Yeah. Now
okay.
these other ones will apply eventually. Like don't
Mhm.
think, oh, I'm never gonna like
All of
that's
them are gonna
that's
be down.
yeah, but not
Okay.
in this problem.
Yeah, okay, got it. Okay, so then we look at okay, 9. So I guess 9 is different because we have a bigger exponent in the numerator.
Yeah. So
4.
this one's considered top heavy.
Because there's the 4.
Yeah, so it's 8x to the fourth over 7,000 x cubed, but because it's top heavy,
Mhm.
that means it either goes to positive infinity or negative infinity.
Okay.
And
How
how
come
do
it
you
can go
decide?
to both
Well, we have to decide here.
of
So
that? Okay.
it depends on the values of x. So
Mhm.
8x to the fourth, like think of whatever number you have. 8x to the fourth. If you a number to the power of four is always positive.
Mhm.
A number to the power of three is, let's say, because you're going in the negative direction, it's negative.
Negative.
A
Okay.
negative times negative is negative. So a positive over negative is negative. This goes to negative
Okay.
infinity.
I think. Okay. And then for the limit, is it the limit does not exist because it approaches
No, it does. The
it
limit does
does
exist because it approaches positive infinity or
or negative.
negative infinity.
I think I'm still kind of confused on how that works.
It's
So
like think of as any number you want that's towards negative infinity, like negative a billion or whatever,
mhm,
to the power of four, because it's an even power. So the idea is that any number
mhm.
to an even power, let's say a negative number to the even power is always
Oh, it's going to be
positive.
positive, but if you
But
have like an odd number,
yeah,
it's gonna still have the negative.
right. When
Okay.
you go the other direction, whether it's positive number to an even or an odd, it's always positive.
Got it. Okay. Okay. That makes okay. Got it. So the limit does exist because it approaches positive infinity or negative infinity.
Yeah.
Yeah. Okay. Okay. And that was, let's see, the limit. Wait, I have to submit this. Hold up. The limit does, or it's showing, wait, the limit does exist because it approaches right here. Okay. Um, oh, I don't know what I pressed. It just, okay, we can move on to 10.
Make a note here.
Yeah, let me look at the dim. Yeah.
So 10 is the same thing, but going, no, it's not the same. Oh, I've got, it was if, no, sorry, I got the wrong thing up. Let me get it up
Yeah,
here.
wait, on 9, I pressed the limit does exist because it approaches positive infinity or negative infinity. It marked it as wrong, which I don't understand.
Oh, sorry.
Yeah, wait.
And did I, let's make sure. Did the negative infinity get accepted?
Yes.
Okay. The limit does not. So let's go for the other one. The way I think the way that the language here is that it's saying uh it only exists if it goes to a finite number.
Mhm. The limit does exist because it diverges. Yeah. Okay, I'll try that one. Okay, yeah, it took that one. The limit
Yeah.
does not exist because it diverges to positive infinity or negative infinity.
All right. So this one is bottom heavy
Mhm.
again. So when it's bottom heavy, it always goes to zero.
0.
And that it does exist. It is a finite number.
Got it. Okay. And then I think I have a snippet. Did you get a snippet of 11? Because there's like now
I
and
do.
yeah,
I do. I got a quick one of 11.
these ones are different.
All
Yeah.
right. If answers is okay, so it says the limit as x approaches positive infinity of this thing right here.
Mhm.
There's a couple of ways to do it. It helps to know that the limit as x goes to positive infinity, e to the minus x always goes to zero.
0.
And that's what you have here. This part
Mhm.
is going to go to zero. And so this is something they would cover in class. They would say, oh, if you get an e to the minus x, it goes to 0.
Zero,
But you got
right.
to be careful here. The limit as x goes to positive infinity of e to the x, it goes to infinity. So that
It's a
negative
positive. Yeah.
makes all the difference. Now, not to confuse you or be like too
Mhm.
confusing, but if it's the limit as x goes to negative infinity e to x, this goes to 0.
Okay.
If it's ends up being e to a negative number. So
Mhm.
there's actually 4 of these to remember.
Mhm.
There's another one associated with this
Mhm.
that we could throw up there. But for your problem here, if this part goes to 0,
Mhm.
5.1 times 0 is 0. 3
Mhm.
over 7 is the answer. There's not necessarily a lot of work.
Work,
There's
right.
just a lot of like things to go
Like,
with.
yeah. So, and then the limit does not exist because it's a
It
negative exponent.
no, it does exist. It does exist. It's a number.
Oh, because we had got three. Okay, so the three out of the three, 3/7 is the number that will let us determine whether the limit will be positive or like negative infinity.
So the fact that it's e to the minus x and you're going to positive infinity tells you what this goes to,
Two, which is 0.
which is 0. And that allows you to then do the rest of it. Like it's really the limit as x goes to positive infinity of 3 over 7 minus 5.1 times 0. And that's why it becomes the 3 over
Over
7.
7, right?
Now the limit exists. Well, if the limit does not exist, say way, but it exists.
Mhm.
It's that last option there.
The limit does exist and is a
Because it goes to a number, so it does exist.
got it. Okay. Okay. I guess I'll share my screen again because it now changes. Let's see. Yeah, these ones I'm not familiar with at all. We haven't done anything like this in class, like yet.
Okay. All right. Yeah, let me grab a couple of these for us to look at. All right, so I grabbed 12 and 13. All right, so if you want to do a few more here, 14. I'll only be able to grab 14. Let me grab 14 real quick. All right, I got 14.
Mhm. I think I also wanted like double check something with intervals.
Sure,
Which is
sure.
like a assignment. Because I was confusing like rate of change with, or not confusing it. I wasn't sure if it's like still the same like equation.
Sure. Do you want to start with these or the other ones? What would be best for you?
Um, we can do the previous ones, then go to the rate of change.
Okay.
Yes, I guess I'll go back.
All right, so I could start here with
Yeah.
12 and 13, or if you want me to, we can grab a few more questions.
Oh, we're gonna start with what we have.
Okay, so let me grab this. Uh, there it is. Now you should be seeing my screen.
Yeah.
So it looks maybe more complicated than it actually is. They're giving you a function P of t, which is this one, C of t, which is this one. So what
Mhm.
they're really asking for is the limit as t goes to infinity,
Mhm.
1.726t plus 20.91 over 1.044t
Mhm.
plus 10.59. Now this one is neither top heavy nor bottom heavy. They're the same.
Mhm.
So the limit is the ratio of these numbers.
Okay.
So you're just dividing 1.726 divided by 1.044.
Okay, I'll type that in.
And 2 decimal places. So I get 1.65. Please double check me on that.
Yep, I got that as well.
And you'll see this a lot in WebAssign where you end up using the same number twice in the interpret. Now you will be expected to write this on a test, on a paper test, this whole thing.
Yeah.
But for now, you can just
As is.
to populate that number in there.
Okay. So all it is basically is just finding the ratio of these numbers.
Yes. Yes.
Okay.
So that was 12.
So,
Let's
so
go to
now
13.
13, we have three equations. So is it similar to 12 or it's going to be a different?
It looks a little different because they're saying PFT over PFT plus CFT plus JFT.
Mhm.
So I guess I will write this out in case you want to see it later. 1.742 T plus 29.84
Mhm.
all over. There's a lot of writing here. 1.74 T 29.84 plus 1.095 T plus 10.65 plus 1.916 T plus 12.36. And that is it. So now
Okay, perfect.
um, it's the same degree on the top and bottom, but you got these T's all over the place. So you really need to combine like terms here.
Yeah. So,
And the constant doesn't matter, but if you're one of those students like you want to be you want to really just get everything down, you do need to combine like terms
yeah.
for it if you want, but really actually doesn't matter in the final calculation.
Mhm.
But I'm going to add up the ones with T.
Okay, me too.
Please double check.
Mhm. So I got four, yeah, 4.753. And then we add the other ones without the T's altogether.
Yeah, you can. It doesn't play into the final answer at all, but just for neatness, there it is.
Okay, got it.
So just like the previous one, it ends up being the ratio here of these. It ends up being 1.742 over
Mhm.
4.753.
Three, and then that's 30.20.
I get I get zero,
Wait, let me try that again.
maybe around
742.
2 decimal places. Okay, 0.37.
Oh yeah, 0. I don't know what I did.
So that's the first answer.
Mhm.
And then it says, okay, if the trend continues indefinitely, will be blank percent. So notice it's converting it to a percent. So
Mhm.
this time you have to multiply by 100,
Which is just 37.
37%.
Okay, that's pretty simple. Okay.
14.
14, yeah. Okay, this one is bar graph.
All right, so they give you data, and then they say these data can be modeled by this equation right here. And they say what happens as it goes to infinity. So
Mhm.
we already looked at this. If we look at just this equation here,
Mhm.
and that's sometimes where it's good to just get it off, get it away from all the other words, the distractions.
Mhm.
Okay. The limit as x goes to infinity, e to the minus x always goes to 0. This part right here goes to 0.
Mhm.
33 times 0 is 0. 573 minus 0 is
573.
573.
Mhm.
So what they're saying is that over time, like there's this like upper bound here, like
Mhm.
it's not going to ever exceed 573.
Got it. Okay.
Any questions on that?
No, that was actually pretty simple. Yeah, and I'm kind of getting the hang of it now.
Okay, so I don't know if there's a 15 or 16, but we can go on to that. You'll have to share your screen, or we can go to 1, 2, and 3 of the other
Yeah, I kind
page.
of want to try the interval ones, or like the tables. Yes, we can do 1, 2, and 3.
Okay. All right, number 1 here.
Mhm.
All right, calculate the average rate of change,
Mhm.
sometimes referred to as AROC, on the interval 0 to 2. So this is the first number is A, the second number is B. average rate of change. You actually did this in your previous course. It's f
Yeah.
of b minus f of a over b minus a. In your problem, it's f of 2 minus f of 0 over 2 minus 0. So f of 2, you got to go to the table. There's 2, 7 is f of 2.
Mhm.
7 minus, and then f of 0 is negative 5 over 2 minus 0.
Mhm.
That becomes 12 over 2, which is
6.
6. 12 over 2 is 6. There we
And
go.
we grab 7 and uh the 7 and -5. Why did we pick those two values? Oh, because it's asking of the interval. Oh, yeah, I see, I see. The
Yeah.
2. Okay.
Yes. Yes. Believe it or not, this right here is the same thing as the slope formula. It just looks
Yeah,
different,
it looks different. Okay.
but it's totally the same.
Okay. So I
All right,
guess
number 2 here.
so the interval is -3, -1, A, B. Um,
It's f of -1 minus f of -3 over -1 minus a -3.
mhm.
So you grab those values from the table.
Which is -1.2 minus 2, 3, and then uh, um, does that become 1/4?
Bottom one becomes 2.
2, because there's
Top
two
one is
negative.
1. Yeah, 0.5 or 1/2, depending on
Mhm.
what
Yeah.
it says there in the box when you put your cursor there.
Um, yeah, it says enter a number, so I think I'll do 1/2.
Okay.
Um, yeah, that was correct.
Right.
3 is okay. So 3 is the same thing. It's just asking for, see, when where appropriate, specify the units of measurement. Yeah. So
So your units of measure, we'll get to that, but it's the y units over the x units.
yeah. 2 and then goes with 6 is 19.9 minus. In the top part of the equation, it would be 19.9 minus 20 minus, oh, sorry, 20.3. Or is it written?
Yep. It's always it's the right minus the left.
Okay. So I got negative 0.1.
Good. And then the y units are millions, dollars and millions. The x units are months. So the drop down there, it's something like millions per month, dollars and millions per month.
Yeah, there's months per dollar, months dollars, years per dollar, and then dollars per month. So
It's in millions. Maybe I don't know if there's a dollar millions, but do that.
um I think it just says dollars per month or years per
Okay.
dollar. Yeah. So it'd be dollars per month, I would just, or
Give that a try. You gotta get a couple of guesses. I can look at your screen if it's not right.
oh yeah, so that dollars per month was correct. It just didn't take the 0.1. So I think I
Oh,
might,
it's negative. You
like,
said
yeah, I put zero, I put negative 0.1.
really.
Yeah.
Okay. Okay. So here's the issue,
Mhm.
and then it's related to that. So see how this is in millions.
Mhm.
So you have to convert this to millions by multiplying by 10 to the sixth,
Mhm.
and that makes it in dollars. So that you're moving the decimal bunch. If you're not
Mhm.
comfortable with that, maybe use your calculator.
Uh,
But it ends up being minus 100,000.
okay, I'll try that one then. Yeah, okay, so that was correct. Okay.
All right, great.
Yeah.
That's all the questions that you sent over. So if you want us to work through a few more, you'll have to share your screen.
Mhm. Yeah, I guess I'll go back to let me see the yeah, I'll share my screen in a second. But these ones I'm still kind of iffy. Let's share screen. Yeah, these ones, I think these kind of freak me out because there's like bigger parts. Um, I guess yeah,
Okay.
15. Yeah.
Why don't I grab all of them this time? So I've taken 15. You want to go down with the rest of these. All right. Let's see what I got next.
There's
I
18.
didn't. Yeah, I didn't get 16 yet. If you want to go back up to that, please. If you scroll down, I think I can get 16 and 17 together. There, I can get that. All right, and then if you want to go down to 18, great, get that. Okay, I got them all. So we'll start with you said 15.
Yeah. Okay, there we go. I see it on
All
my
right.
screen.
All right. So the following approximately popularity of Facebook and YouTube among social media sites. So Facebook, here's the equation. YouTube, here's the equation. We
Mhm.
just want the limit of f of t, f of t. So we only care about the top function. We want the limit as t goes to positive infinity minus 3t squared plus 19t plus 32. Now, if you were to graph this function, it
Mhm.
would roughly look something like this. Okay,
Mhm.
meaning it's U-shaped, it goes down. Now, positive infinity, what this means, it means to the right forever.
Mhm.
So if you were to traverse this curve and put your cursor there on the curve and you were to go to the right forever, what
Mhm.
happens to the Y value?
It becomes like negative forever.
Negative infinity, yeah.
Okay.
Okay. So now to interpret your answer, in the long term, the popularity of Facebook among social media sites will
About
decrease without bound. It just goes down forever,
forever.
forever. Yeah.
Got it. Okay, got it.
Okay. Now the next one here is related to the first one. It's the ratio of f of t over y of t. So we gotta look at like this top one over this bottom one here.
Mhm.
So to do that, I'm going to sort of use my copy and paste feature here. Let me
Mhm.
look at this. Won't do that. Okay. So imagine there's a division bar here,
Mhm.
fraction bar there. So it's got the same degree in the top and the bottom.
Right.
So it becomes -3 over -1, which is
3.
which is 3.
Mhm.
All right, so there's your answer. It's 3. In the long run, if the one on top, Facebook, will be more popular than YouTube, which we know is, I don't believe that's true. I think YouTube is bigger. But anyway, uh, YouTube's the second most popular search engine.
Mhm. Long-term
All right.
fiscal.
Uh,
Yeah.
I don't know in the last one. I
Mhm.
guess I guess I'll go with that one, but
Yeah. Okay, I'll try it out and see.
you can decide. I guess you get maybe more than one guess on that.
Yeah, I think we do. Yeah, so let's see. Yeah, first one was correct. Second one, it's actually the second option that says extra. The models will obtain long-term prediction, giving meaningless results.
Okay.
Yeah.
All right.
Okay. Yeah. Okay. There. Okay. Okay. Got it.
to 16 is next. Percentage PFT of children who can speak at least single words by the age of T months can be approximated by the following equation. Okay. What's the limit as T goes to infinity? So it again kind of probably looks more complicated than it actually is.
Is it just bottom heavy? Because the
Exactly. So that means that the part that I'm trying to write here on the right, which doesn't really matter, this whole thing goes to zero.
row, yeah.
So it ends up being 100, 1 minus 0, which is 100.
Yeah.
Percentage we learn to speak approaches 100%. It's another one of those where you grab that number from the previous problem
I just
and
want you to write it like in a sentence so you understand
then
the concept.
interpret
Yeah.
interpret the results.
Okay. Okay, yeah, 17. This looks the same. So loud. Okay. So 17 is a percentage of the percentage of approximated.
All right, so we want down here the limit T goes to P of T minus Q of T. So
Yeah.
let's first focus on this one right here. You can see that this again goes to 0.
Oh,
So this again goes to 100 minus 1 minus 0, which is 100. This one on the right also goes to 0. And even even though there's a 10 to the 17, it's the variable that you're looking for.
Got it.
It's not this can be anything. So this also goes to 100 times 1 minus 0, which is 100. So it looks like it's 100 minus 100, which is 0.
And it will be children who
So I think what they're trying to say here is that
children
single words.
slide along. Would be they have a harder time learning to speak?
I think intuitively, it seems like if you know more words, you should have an easier time learning sentences.
Yeah.
But I don't know. So I think it's easier. I think it's A, but we've seen how my guesses are, so you can sort of navigate that on your own. Do you get extra credit if you finish this early?
Yeah, we do.
Good. So that might be a reason to do these early so that you can avoid, some of these issues with wondering
Yeah.
what's going on here.
Yeah, I also selected A. That was not correct. Let me try it again. Yeah, okay. I think I'll just have to rely on extra credit for that one. Yeah. Okay, so I guess 18 is the last one, and then we're
Right, so they give you a function IFT for imports, EFT for exports, and then they ask you about the ratio IFT over EFT. So it's again, it's a like you're looking at the power terms, that T squared and then the 0.8 T squared. Since they're the same, it ends up being 1 over 0.8. Okay, which is whatever it is, 5/4. I think it's 1.25.
Yeah.
For that one. For IFT, when you're just looking at the original IFT, I missed that here. You look at the graph, like what's going on with the graph here, and T squared is upwards. So when you go to the right forever, it goes up forever to positive infinity.
Yeah.
Okay, in the long term, US imports from other countries will, I don't know, increase, it'll rise. The positive means it goes on forever and will be 1.25 times that. So it's pretty common in WebAssign to have your boxes.
The same.
and I don't know, can it be extrapolated in the future? I don't know whether you can. I'll say yes. Probably wrong.
Let's see. Could the models be?
Actually, extrapolation is very dangerous. It probably is. It probably actually is no, because you don't generally extrapolate data. It's a violation of something.
Yeah, all of those. Yeah, that was correct. Yeah, it's not. Yeah. Okay. Okay, perfect.
All right,
Um,
I think that's everything you've
yeah,
sent over
that was
so far.
everything. Yeah. Yeah, that all worked out.
Okay. Anything else for today?
I think that was all that I needed help with. Yeah.